Hello everyone, welcome back to my YouTube channel. This is Nehati from Sri Venkateswara College of Engineering. In today's video, we'll be seeing about dynamic memory allocation. So without any further delay, let's get into the video. So today we'll be seeing arrays, that is just the definition of arrays, then types of memory allocation, that is static memory allocation and the dynamic memory allocation. We'll go with, after that, we'll be seeing the functions of dynamic memory allocations, and finally we'll conclude with the conclusion. So what is array? We all know array is a collection of similar data types, and this is stored in a contiguous manner. It can be used to store the collection of primitive data types such as int, float, character, etc., and also the user defined data types like the pointers, structures, etc. So coming to the types of memory allocation, the first one is a static memory allocation. Static memory allocation is also known as the compile time memory allocation because the memory is allocated for the data during the compile time. This cannot be changed, it is fixed, and we cannot deallocate or reallocate the memory in the static memory allocation, because once the memory is given during the compile time, there cannot be any changes made in that. So static memory allocation is also known as the compile time memory allocation because the memory is allocated during the compile time. In this type of memory allocation, the memory that the program can use is fixed. We cannot allocate or deallocate memory during the program's execution. In many applications, it is not possible to predict how much memory will be needed for the program at the runtime. In some programs, we might not know how much memory is needed, so we might give extra amount of memory, but we are not going to use so much, so there will be wastage of memory in the program. So to avoid this, we'll be using the dynamic memory allocation. So coming to dynamic memory allocation, it is also known as the runtime memory allocation because the memory is allocated during the runtime. The allocation and release of the memory can be done using the library functions of standard library.h. It is standard stdlib.h header file. There are four functions used in dynamic memory allocation, that is the malloc, calloc, realloc, and the free functions. First one, we have the malloc, and M in malloc is refers to the memory allocation. So malloc, in malloc, when we are declaring malloc dynamically, when we are allocating the memory using malloc, a single large block of memory is allocated, okay, with specified size. That is just a single large block of memory. It's not divided. It's just a single one. It returns a pointer of type void, which can be cast into pointer of any form. Okay, it returns null if the memory is not sufficient. It doesn't initialize memory at execution time, so that it has initialized each block with the default garbage value initially. Okay, so the main point here is it just allocates a single large block of memory of the specified size, and the second one is it returns null if the memory is not sufficient. Coming to the syntax of malloc function, it is pointer is equals to cast type star malloc into malloc in bracket the byte size. So if you're writing more easily, like if we go to the next step, it is like pointer is equals to the data type star malloc function keyword into n will be the number of elements, star size of the data type. Here we're taking int, so we're taking the size of int. So coming to this, int star pointer is equals to int star malloc 5 is the n, the number of elements, size of int. So size of int is basically taken as 4. So the size 5 into 4, so 20 bytes of memory, one single block of memory will be allocated using the malloc function. So coming to a program using malloc function, we'll just see one program. We'll see an example program here. We'll use the stdio.h header file, and then we need the standard library.h header file because we're going to use the malloc function here. Then we'll give a pointer as int data type, and then I also as int data type. Printf enter the number of elements. So we'll ask the user for the input. This input will be stored as n. Okay, because and %d is here because we are taking in data type. Printf enter the entered number of elements %d. What is stored as d, that is n. What is stored as n will be taken here That is what the user has given the input. Dynamically allocating memory using malloc, we have the pointer is equals to int star, the data type star, malloc, and open the bracket n star size of int. This is the syntax for the memory allocation using malloc function. So int is a data type, malloc keyword, n star, n is what? N is the number of elements we have taken here, size of int. So if pointer is equals to null, we've seen if a pointer will be shown as null only if the memory is insufficient. So we're going to print memory not allocated, exit 0, we're exiting the program, or else we're going to write memory successfully allocated using malloc for I is equals to 0, I less than n, I plus plus. If we're taking the n, and we're taking here as 5. So if n, I less than n will be till 4. So I is equals to 0, it's starting, I will go till 4, I plus plus. Pointer of I, that is start pointer of 0 is equals to 0 plus 1, 1. So pointer of 0 is 1, pointer of 1 will be 2, pointer of 3 will be, pointer of 2 will be 3, like that, till pointer of 4 is equals to 4 plus 1, 5. So here we'll get elements of, when we're printing the elements of the array, we'll give for I is equals to 0, I less than and I plus plus. Print f %d pointer of I. So till here we'll go, and then we'll get the output as 1, 2, 3, 4, 5, return 0. Okay. So this is the program for malloc function. Next one is the calloc function. C here stands for contiguous allocation. Contiguous allocation means that it is in a continuous manner. Calloc or contiguous allocation method in C is used to dynamically allocate the specified number of blocks of memory of the specified type. So there it was just a single block. Here we'll give number of blocks. How much the value of n is, so many blocks will be given here. It is very much similar to malloc but has two different points. These are, it initializes each block with a default value 0. Okay, it has two parameters or arguments as compared to malloc. In malloc, which is having one, we will have two. Syntax, coming to syntax, it is ptr is equal to cast type star calloc n and element size, which can also be written as ptr is equals to data type star calloc 5 is n and element size is size of integer. So that time it was malloc 5 into size of integer. Here it is 5 size of integer. So if we give like that, we'll get 5 blocks of memory of size is 4 bytes. Okay. So saying the program, going to the program for calloc function, we have hash include, the two header files we'll write, int main, int star ptr, int n and I again, same thing, a printf, enter the number of elements, we are storing it as n. Then here, this is the only line that is different comparing to both the programs. ptr is equals to int star calloc. Calloc is the function, n. N is what we've taken here and size of integer. So we've taken 5, it will be 5, we'll get 5 blocks of size of int, that is 4 bytes. So if pointer is equals to 0, memory not allocated, exit the program, or else printf memory successfully allocated using calloc. For I is equals to 0, I less than and I plus plus. Print I is equals to I plus 1. Pointer of I is equals to I plus 1. Printf, the elements of the array are for I is equals to 0, we're printing that. Okay, printf %d, that is pointer, I will be printed. So the same thing we'll be getting here. The only difference is the there we use malloc and here we're using calloc. Okay, next we have the reallocation function, that is realloc. Reallocation. Coming to realloc, realloc is used only when we have to reallocate the memory that we've already assigned using malloc and calloc function. So realloc or reallocation method in C is used to dynamically change the memory allocation of a previously allocated memory. Since previously allocated memory is done using either calloc or malloc, this can be changed using realloc. If we ever feel like this size should be increased or decreased, we can use realloc function. So in other words, if the memory previously allocated with the help of calloc or malloc is insufficient, realloc can be used to dynamically reallocate the memory. Reallocation of memory maintains the already present value and new blocks will be initialized if the default garbage value. The space is insufficient, allocation fails and returns a null pointer. So it is like reallocation of memory maintains the already present value. We'll already have the value memory we have assigned using calloc or malloc, and the extra will be added if we use the realloc function. While coming to the syntax of reallocation function, pointer is equals to realloc pointer comma new size. So here the new size refers to the size we need. We like if it's insufficient new size we need for the memory location. So now realloc we have to see that int star ptr is equals to int star malloc 5 into size of int. Okay, so this is allocating memory using the malloc function. So this will create a single block because it's malloc. It will create a single block of memory of 20 bytes. Then PTR is equals to realloc. We need to change. We don't need 5. We need 10. So we'll give the realloc function pointer, comma 10 star size of int. Okay, 10 star size. Here it is 5 star size of int. Here we'll give 10 star size of int. So we'll get 10 into 4, that is 40 bytes of memory. Since it is the malloc function we use here first, we'll get one single large block of 40 bytes of memory. Coming to the program for the reallocation function, hash include these two header files will be using int main. Okay, int star ptr int n and I we are taking n is equals to 5. Okay, we are already declaring n is equals to 5. Printf enter the number of elements %d. Here already since it's given n is equals to 5, we'll give n. N will be entered here, so n will come as 5. Pointer is equals to int star calloc n size of int. So here it will be 5 and size of integer is 4. So if pointer is equals to null, memory not allocated. That is, if the memory is not sufficient, we'll give memory not allocated. Else, memory successfully allocated using calloc function for I is equals to 0. This is the same step we use that. What will we get? We'll get this 1, 2, 3, 4, 5 as in the similar to programs. Then we'll get n is equals to 10. We'll declare again n is equals to 10. Printf enter the new size of the array. 10 will come because we've already given the value as 10. Pointer is equals to int star, the data type is int, reallocate pointer, okay? Pointer and n into size of int. So 10 into size of integer will come. Printf memory successfully reallocated using realloc. This sentence also will be printed. Now for I is equals to 5, I less than and I plus I. Here we've already given the 5, okay? So we're starting from I is equals to 5 till I less than n, that is till 9 will come. But pointer of 9 will be equal to 9 plus 1, that is 10. Now printing the elements of the array, it will start from 0. We need from 0 till 10, like from 1 till 10. So we'll take from 0. I is equals to 0, I less than n, that is still 9. I plus I, printf %d, pointer of I. So the pointer of I till 5 is given over here. From 6 to 10 will be given over here. So we'll print that also. %d pointer of I, return 0, we'll get 1 to 10. Okay. So the last function is the free function, and in free function, we have free method in C is used to dynamically deallocate the memory. Till now we were allocating the memory. To free the memory, we're using free function. The memory allocated using functions malloc and calloc is not deallocated on their own. So to reduce the wastage, we'll be using free function. So hence the free method is used whenever the dynamic memory allocation takes place. It helps to reduce wastage of memory by freeing it. Okay. So just a syntax free, and in bracket we'll be writing pointer. So this is memory allocation using calloc. 5 blocks of 4 bytes will be created. After the operation is done, this memory we'll have to deallocate it. So we'll use a free pointer and this will go to the bin. That is how free function works. Coming to the program, we have the two header files, int main, int start ptr, int n is equals to 5. Okay, so here we don't need n is equals to 5. We'll just write int n, okay? So pointer, printf, enter the number of elements. We'll ask the user, we'll take the user input. So we'll ask the user what the input we need. Scanf, %d and %n. So the thing is, we don't need n is equals to 5. We can just give as n, okay? this will be how it is. Okay, let's do this. Okay. So after this, we have in star ptr is equals to null. We're taking the user input n, and then that will be stored as n. The use what the user gives here we've taken 5, so it will be stored as n. We'll be allocating memory using the calloc function. If pointer is equals to null, memory not allocated. Exit, that is exiting the program. Printf successful or else. This is else function. After if this is else, printf successfully allocated. So here memory allocated successfully. Free pointer. After we've done free the pointer. Okay. Printf calloc memory successfully freed. That will also be printed. Okay. Return 0. We'll do a thing. We'll just try it in the compiler. My VS Code has some problem, so we'll just do it in the online compiler. Okay, so we've taken printf, same thing, we've taken n, enter the elements, pointer till here is set, successfully allocated the memory using calloc, free the memory, we're freeing the pointer, printf calloc memory successfully freed. Okay, enter the number of element, we're asking the user for the element. 5 only will take successfully allocated memory, this line is being printed. Then we have printf calloc memory successfully allocated. Okay, this is also done. So this is how we have to do. Next, coming to the now all the 4 functions of the dynamically allocated memory is there. So we have the last part, that is the conclusion, and then we'll conclude the video with that. So why we use dynamically allocate dynamic memory allocation than using static memory allocation? We'll just see. Dynamic memory allocation allows for flexibility and efficiency, as the size and location of the memory blocks can be changed according to the program logic and data type, which is not possible in the static memory allocation because it is fixed during the compile time. It also enables the creation and manipulation of complex and dynamic data structures such as linked lists, trees, graphs, and hash tables. Furthermore, dynamic memory allocation allows the program to adapt to different environments and user inputs, as the memory usage can be adjusted at runtime. This is the advantages of the dynamic memory allocation, and so since the dynamic memory allocation has an upper hand compared to the static memory allocation, we prefer using the dynamic memory allocation. So this is all about today's video. I hope you all could learn something from the video, and thank you for staying with me till the end. Thank you very much. I'll be ending it. Thank you.